is near, we are going to be finishing out our activities from lesson 5 in the next couple of videos. Have a highlighter, have a protractor, have a pencil, have something to write with, have a compass, and then have some patty paper. And I'm going to show you a special piece of patty paper that I've saved since lesson 3. And if you've saved it too, you're smart. If not, go back and watch one of those videos from lesson 3. Good luck finding it. And then you'll see what I'm creating with that, and you can go ahead and create it from yourself from watching one of the previous videos. This lesson on investigating the Orthocenter is directly connected to our learning goals. Use points of concurrency to construct the inscribed and circumscribed triangles, or circles of a triangle. Not that one. We're going to construct the Orthocenter. That's what this video is about. So, page 272, page 272. Let's get into it. The habits of mind. As a good person learning, or as a person that is becoming a good mathematician, we need to look for and make use of structure. So I hope you have the patty paper that I'm talking about, or go back and find it, because that is a structure that we're going to continue to use. And then look for and express regularity in repeated reasoning, how we understand the structure and the nature of things. We're going to make an altitude of a triangle. So an altitude of a triangle is a line segment that is perpendicular to a side of a triangle and has one end point on the opposite vertex. You'll see it as I create it, but think about what that means. I'm going to draw the lines of a triangle so that the one corner of the triangle makes a directly perpendicular line segment, or ray, if you will, or however you want to define it, to the opposite side. It's not a perpendicular bisector that cuts the line in half. It's an altitude. Here's the device that I'm going to use. I created a piece of patty paper that has a perpendicular line segment. In fact, because of the way I created it, this is actually the perpendicular bisector, but all that I really care about is the fact that there's a right angle. I don't need to know the perpendicular bisector part of it, but I need the perpendicular line. I flip the paper over. That's a key part of it. And then I'm going to slide the paper over so that the perpendicular line is crossing the vertex and the bottom edge is actually on top of a side of the triangle. And so a little bit of adjustment here, and I'm going to put a mark. So I know that this line is going to, maybe trace it, but I'm going to remove the trace here in a minute. This line that goes through the vertex of the triangle is going to connect the opposite side, and where they cross will be a perfect 90-degree angle. Let's see what happens when I remove the tracing paper. Remember, I had flipped it over, so I'm tracing my trace. Altitude. Do the same thing for all 3 sides. Maybe a little rotation of the book, of the paper. You want to make sure that your line segment is on, right? Kind of turn the book around so you see it, the triangle looks about the same. The line segment that I drew for my perpendicular bisector is on the side of the triangle, and then the perpendicular line is passing through the vertex. So like that. Remove the tracing paper and see the light line that has been pressed onto the paper. You can probably get away with flipping the paper around, flipping the tracing paper around. I'm going to reset the book so we can only focus on just this one. And again, line it up so that you are putting your line segment on the side of the triangle, and the perpendicular line goes through the angle on the opposite side, on the opposite area of the triangle. So angle, opposite side, drop in the altitude. Let's see. Be precise. They are concurrent. Remember, all of these constructions that we do create points of concurrency. And if it helps, maybe bring in a ruler, trace the lines a little more bold. Make sure that they're visible as altitudes. They've made 90 degrees, 90 degrees, 90 degrees. I'm going to speed through the other ones. You've seen the process for this one, so maybe just feel free to skip forward in the video, a minute at a time or so, just to accelerate what you have to see. It really helps to have the tracing paper with the perpendicular bisectors constructed on it. Note, you could have cheesed it by just tracing the corner of a box. Because a computer does things with precision and accuracy, something that we as humans strive for. Tracing like the T, where the box is created, also creates a perpendicular relationship. And so I can just flip that around, line up my lines, line up my angle, and trace an altitude. That's a fresh, quick way to do an altitude of a triangle. Trust me, on the obtuse one, we're going to need the other one. So I'm going to go ahead and create it. Maybe I'll talk a little bit through it, but you're welcome to skip forward in the video just to see how I do it. Because this angle crosses this side, but not like over here. It's going to cross it like in this direction. I'm actually going to want to lightly extend this line. So here we go. It's not even on the right spot. There we go. It's a little better. Precision, sir. And then do the same thing. Extend this other line. I'm going to do two at once. So extend this line out. Have to do that. It is evidence we're going to erase, but because we want to make sure that this side, that's the opposite side of this angle, that we do still line it up, but it's going to line up outside of the triangle. And that's okay. It's totally okay to do. Obtuse triangles just work that way. Okay. Pretty good. Now I'm going to go to the other side that I haven't crossed yet. I haven't really drawn in the altitude here. So from this angle to the opposite side, we want to go directly there in a perpendicular fashion. So use my perpendicular bisector, line up my segment with the side, but now slide the perpendicular bar over to the angle. And then drop in the altitude. Perfect. Since they don't meet, and trust me, concurrent, like all of these creations we've done for lesson 5 are concurrent. I need to extend the line, but I'm going to use my straight edge to do that. The tracing paper did its job. It did its function. I think I see this one a little bit clearer right now, so I'm going to draw this one first. Am I lined up? Am I lined up? Here we go. And I think if I did it right, if I'm off by a little bit, I'll kind of cheese it for right now. I'm off by, no, I'm not really off at all. But they are concurrent up here. And now to erase the evidence. I don't really want to erase it, but I just want to convince you. Like, we don't need all of the pencil marks, so they could go away. Now for the right triangle. See, for the right triangle, it should go right through the angle. It should be a bisector. In this case, the altitude and the bisector are the same. And then because of the right angle, this is kind of like the cheese part here, my perpendicular bisector is going to be actually right on that corner. Because this is an altitude for that angle, this is an altitude for that angle, and then this is an altitude for that angle. So all three angles have their altitudes drawn. It's just that they meet on the corner of the triangle. Orthocenter. Orthocenter. I'll let you do equilateral triangle. You do this one. You do it. Okay. Hey, welcome back. Pause the video right here. Get to part 2. We're going to finish out the question here at the bottom of the page. Okay. Make a conjecture about the location of the intersection of the 3 altitudes of any triangle. Is the intersection located inside, outside, or on? And I've hinted at that by showing you in an acute triangle, the orthocenter is inside. For an obtuse triangle, the orthocenter is outside. And for a right triangle, the orthocenter is on the edge, or actually on the right angle of the right triangle. So I'm going to write all of that up. Probably just go ahead and skip forward in 10-second chunks at a time so that you can see what I'm writing and you can just pause and reflect in your own speed, space, and time. For 3 altitudes. No, I'm not gonna say it out loud. You can read it. You can write it. Hey, thank you for watching page 272. I'm going to get page 273 here. And then as I look forward, I believe, yeah, for sure. I will give you a talk-to-talk video as well. And then this is the complete lesson 5 done. Thank you for watching this video. Ask yourself these questions and maybe we can have a conversation about it in a little bit. Question number 1, which construction did you use to construct the altitude? I wonders me wonders. How does the point of concurrency in the acute triangle differ from the point of concurrency in the obtuse triangle or from the equilateral triangle? How does the altitude compare to a median? Go back and look at centroids for the conversation on medians. How do these two things compare? Could you have determined the point of concurrency by constructing only 2 altitudes of each triangle, or do you have to construct all 3? And with that, excellent questions to ponder and consider. Let's talk about it when we get a chance to. Thank you so much. Have a good day.